Alright, so this is the finished version 1 of my Tesla coil, spark gap Tesla coil. So starting from the input, we have a ZVS driver running off of 19 volts, going into a low ratio flyback transformer. It steps it up to 1 to 2,000 volts, which is fed into the classic spark gap design. Spark gap, 60 nanofarad capacitor, primary coil near the center of the secondary coil for high coupling. Bottom of the secondary coil is grounded using both a counterpoise, which is the aluminum foil, and a somewhat long wire leading to a copper pipe. And is very effective. So here's a shot of it running at maximum frequency, lowest voltage. And adjusting it for a higher voltage. And you'll notice that the delay between each spark is pretty large, and that's because I have a massive high voltage resistor here, because these diodes, I don't have the right diodes. They're only rated for 5 milliamps, and ZVS drivers do not put out just 5 milliamps, you know? Another thing, I'm just kind of troubling. Let me adjust the spark gap. So you'll notice over here, there are sparks in the flyback transformer. So the voltage from the Tesla coil is actually going back into the input circuitry and potentially damaging it. Luckily, this type of transformer is homemade but very durable, since it's a very thin disc of just wire. Very simple. Very high voltage. So I'd probably have to insulate this in oil or some similar method, but I have to insulate it. And also sparking down to the edge of the disc over there to the core. That would be difficult to protect against. So oil is probably the best option. But probably not right now, because I plan to get at least 2 more discs on the core here for 3 times as high of a voltage, 3 times as high as an output, and then I'll probably have to insulate it in oil, because that's kind of dangerous. That's all I can think of right now. And another thing, all the way across the room from here, this multimeter can detect electromagnetic signals from it. And so that should be a very strong indicator that if you're going to run this on any higher powers, like any shorter duration between the sparks, you have potential for damaging some kind of equipment in your house. which is why people use big Faraday cages around their entire Tesla coil, if it's big enough. That way signals won't get out. Potentially radio people could track you down if they think that signal's suspicious enough. And hopefully you're not stupid enough to use a multimeter on the output of any part of this, because that'll destroy it. Just having your multimeter around can destroy it. Having your smartphone right next to it could destroy it. Just recording this while it's running is kind of risky. But it's not that high power right now, so it's alright. I guess just stay tuned for version 2. I can smell ozone.